Good morning. Welcome to the ICME Journal Computing Information Science JCISE Spotlight Talk. Today, it's my pleasure to introduce our speaker, Professor Jianxi Luo from Singapore University of Technology and Design. SUTD is one of the, I would say, it's very unique university in the world. Integrated technology and design. It's very impressive curricular program. Professor Luo is expert in the domain of data-driven innovation. And today we have a good opportunity to learn about the ChatGPT and for its use for engineering design. Professor Luo.
Okay, thank you, Prof. Wang, for the intro, and also thank you very much for spotlighting us, our work on generative pretrained transformers for design concept generation. You know, ChatGPT went viral in November last year, but actually this research was started almost 2 years ago, long before ChatGPT was launched. And when we first saw GPT-1, GPT-2, and GPT-3, and we were very impressed by the generative capabilities of those large language models. We sensed that it could be very useful for design concept generation, and almost 2 years ago. And then we started running a few experiments, and we summarized our findings from those experiments in this paper published by JCISE. And today we're very honored to have this opportunity to share and our results on using GPT for design concept generation and to the ASME community. So when it comes to design concept generation and also designing AI to do that, and we first started with a design creativity series on how human designers generate design concepts. Right? Actually, when we generate new ideas, we're not creating anything from scratch. We're just transforming our prior knowledge into new ideas, new concepts through creative reasoning based on different types of logics, right? And so that means the knowledge and also the creative reasoning logics are both important for design concept generation. And based upon that, we developed this taxonomy to categorize and classify different design and concept generation support methods and tools according to what extent computers have been used and to augment reasoning and knowledge in concept generation. For example, at the bottom left corner, brainstorming is a very powerful human conduct for concept generation, where we use our human knowledge and also use human reasoning to generate new concepts. At the bottom right are the knowledge-based systems or biomimicry design repositories, and those provide external knowledge to inspire human designers to generate new design concepts. And human designers still need to reason and conduct creative thinking and to observe the external knowledge provided by computers and databases for concept generation. In the upper row on the left, you see those generative algorithms, topological optimization, parametric design. And those are based on computer reasoning, but the models are largely defined and designed by human using our own knowledge. And this work actually is in the upper right corner of this spectrum, this two-dimensional space. And we're looking at a fully automated design concept generation with using computers to reason and using digitalized knowledge to reason and generate new design concepts. That's about designing AI for design concept generation. Actually, at the beginning of this research, we also carefully thought about the different roles that AI can play in the concept generation process. And AI, at least, can be used as a guide to record and organize and facilitate group or individual ideation and to support human designers generating ideas. And secondly, AI can be used as a stimulator to provide external knowledge or structural heuristics to inspire human designers to generate better and more ideas. In the third case, which is the focus of this study, AI can just generate ideas using digital knowledge and computerized design heuristics. In that case, it presents full artificial creativity for concept generation, AI can play a role as a brainstorming partner in the design concept generation process. And that is our interest in this research. And when we talk about AI for design or generative design, we often refer to topological optimization, parametric design, or deep generative models such as GAN, or the most recent text-to-image generative design models such as DALL-E or Mid-Journey and Stable Diffusion. And those approaches are visual and spatial and parametric. They're most useful for a later stage embodiment design or detailed design or optimal design when after the concepts have been generated and fixed. And our work is complementary, and we focus on the early stage conceptual design. And for that stage, when we generate the first idea, solving a problem or a new problems, and we often do semantic reasoning. So in this case, text generation based on semantic reasoning will be most relevant. And for this purpose, the large language models, and such as the BERT and the GPT, will be perfectly suitable, and especially GPT, generative pretrained transformers, which are a subset of large language models and present generative and text generation capabilities that can be a very good basis for generating a new design concept in the text form. So those large language models have been pre-trained based on massive data sets, mostly made of text, but sometimes also images and equations and other modalities. And they're pre-trained, they already have a lot of knowledge, and for the use in different specific downstream tasks, they can be customized and fine-tuned and also repurposed through prompt-based learning. The assumption that those large language models have already learned massive cross-domain knowledge, and that can be the input for design concept generation. What we need to do is to teach those large language models and how to reason like creative designers do. And also evaluate the AI-generated concept in terms of their novelty and usefulness, because we're not just generating common sense text for other purpose, we're generating design concepts represented in natural language text. So there are two ways of working with GPT or pre-trained language models for our purpose. One is to fine-tune such pre-trained models with already pre-trained with a lot of data. We further use a data set to fine-tune these models to modify the neural network weights for specific use of specific NLP tasks or energy tasks in the downstream. So the data set will contain the logics or the knowledge required for the specific downstream task. So the fine-tuned model will just do the job as we need it. Prompt-based learning doesn't require fine-tuning. It doesn't change the model, the pre-trained model, but just interact with the model with prompts to influence the model to generate content in certain ways that's useful for our purpose. That's exactly what ChatGPT does, and which is about chat completion. When we provide a prompt of instruction, ChatGPT and other models will Q&A chat models will complete a response to finish this conversation or a chat. But our work is different. We focus on text completion and completion of a text that represents a design concept. In this case, we provide a prompt of condition. Then the AI model will complete the text following the prompt of condition. So the text actually represents the design context. So in this case, we need to create a data set for fine-tuning or future learning. The data set needs to contain the condition and concept pairs, which embed the knowledge or the reasoning logics that we want GPT to follow for concept generation. And after that, we can then we provide the input condition, a new input condition to the fine-tuned GPT model to generate new concepts. And the generated concepts in text form can be evaluated in text embeddings because they're presented in natural language. And in this study, we explored two metrics to measure the originality or novelty of the concept generated by AI. One is to use semantic distance between the generated and based on text using the word over distance. So so when we generate a paragraph, when AI has generated paragraphs, and we can compare the semantic distance of those paragraphs to the baseline text representing some common sense ideas or knowledge in the domain of concept generation to evaluate the originality. If the distance score is greater, it means the novelty of AI-generated concept is higher. In the second case, we look at the semantic relevancy among the terms in generated text. We don't need external benchmark, just look at the pairwise semantic relevancy within the text generated and focus on the minimum score as an indicator, opposite indicator of novelty. The relevancy scores are drawn from a pre-trained large technology semantic network, TechNet, and which contains more than 4 million and technical terms and their pre-trained semantic relevancy scores, which is leverage TechNet to provide and those semantic relevance scores to evaluate the novelty of any AI-generated text in terms of novelty of the concept they represent. So we run 3 experiments. In the first experiment, we try to control for the knowledge input for design concept generation. And in the second and third experiment, we try to control for the predictive reasoning logics. One is a problem-driven logic, and other one is analogy-driven reasoning. And we export the USPDO pattern database and Red Dot award-winning design datasets for fine-tuning or fusion learning of GPT or GPT-2 or GPT-3 models. And we use the TechNet and the WMD to measure the novelty of the AI-generated concepts. So in the first experiment, we use the pattern text titles, which are short sentences representing different design concept in the pattern database from 6 specialized domains to fine-tune the generic GPT model into domain-specific AI expert. Then we ask those individual specialized domain AI experts to generate design concepts relevant to rolling toy, which is a specific design target. And in this case, we created fine-tuning data sets based upon the pattern title structure. We first extract keywords from each title in the fine-tuning data sets, and then we use the pairs of the keywords and the titles to fine-tune the GPT model. The fine-tuned model then is used with the new keywords as the prompt of condition. The new keyword in this case is rolling toy as a prompt condition to stimulate this AI model fine-tune GPT to complete a sentence that is a new design concept. And we also created a small fusion learning sample of 10 keyword and pattern title pairs to allow GPT-3 to learn about this logic and or the control of a domain knowledge for concept generation. So with the 10 examples, GPT-3 actually learned about this logic very well. And also when we provided this new condition, which is a keyword rolling toy, GPT-3 generated many novel and meaningful concepts only after fusion learning with 10 samples. So the concept generated with both models actually exhibit novelty. And then we also found the novelty of those concepts as evaluated based on TechNet actually is highly related to the knowledge distance between rolling toy, that's the design target domain, and also the knowledge base of the fine-tuning data sets for fine-tuning those AI models. The knowledge distance here is evaluated based upon our technology space network map from a prior study, GPS, in which we quantify the knowledge distance between hundreds of engineering design domains. And we just drew the quantified knowledge distance scores from that study to measure the distance between rolling toy and the 6 specialized domains from which the fine-tuning datasets are joined to fine-tune and train the GPT models into domain-specific AI experts. And later on, we also utilized pattern and abstract text from 72 domains to fine-tune the generic GPT-2 model into 72 domain AI experts. Then we ask this set of 72 AI experts with a different knowledge specialization to generate role-deployed design concepts. And it shows clear pattern that the novelty of the concept generated by an AI, especially in different domains, actually is the novelty is highly correlated with the knowledge distance between the design target and the knowledge base of those AI experts. So those results actually suggest that novelty of the AI generated concepts is potentially controllable by knowledge distance between the design problem and also the knowledge that AI models draw to generate the concepts. In the second experiment, we try to control for the problem. We provide a problem and for the AI models to generate design concepts. And to explicate that logic for GPT-2 and GPT-3 to learn. And we look at the design award-winning design descriptions from the Red Dot Award websites. And if you look at the example design description from Red Dot Awards, you see, and most of the design description includes paragraphs, sentences describing the problem and also sentences describing the solution. And so we use such design descriptions with a clearly specified problem and the solutions, and also the design concepts categories to fine-tune the GPT model. Then we provide a new problem as a condition for the fine-tuned GPT model to generate new solutions. In this case, we experimented with the 3 types of problems. One is existing problem with an existing solution from an IF design website, which is a competing award, design competition website, competition with the Red Dot Award. In the second case, we slightly revised this IF design problem and the solution into a new design problem. And in any case, those problems are all about ECG testing, electrocardiography testing process. And so in the first case, the first problem had a solution from IF design. The second one is a slightly revised new problem, which has no low-in solution. In the third case, we just use the open design context, ECG, as the problem input to allow GPT model to generate open-ended design concept related to ECG testing. And our results, the AI-generated concepts all exhibit novelty to different degrees. And the existing problem actually led to the generation of more similar solutions with the existing one. And the open-ended problem and the new problem without a solution actually allowed the model to generate more novel design concepts based upon the WMD distance to 2 benchmarks. One benchmark is the original design solution concept to the existing problem from IF design. And the second benchmark is a paragraph describing ECG from Wikipedia, which represent a common sense description of this technology called ECG. In the third experiment, we try to control for this design creative reasoning called analogy or design by analogy. It's a specific way of thinking to generate design concepts. And so we look at the design descriptions from Red Dot Award website. We found many designs are actually designs by analogy, and there's a clear analogy logic described in those paragraphs. And so we explicated the analogy, especially the source and target domain, and as the condition, and also the design concept description in a separate paragraph to design the pairs for fine-tuning and to create this future learning samples for fine-tuning GPT-3 into analogical reasoning experts for design. And with a small number of learning samples, GPT-3 actually learned about design by analogy very well. And we asked this GPT-3 analogical reasoning, analogical design experts to generate design concepts related to John, but with inspiration, analogical inspiration from 5 different domains, including airplane, bird, an insect, lantern, and poetry. And the AI agent actually generated very novel and also feasible, inspiring concepts. And all those concepts exhibit novelty to different degrees according to our evaluation based upon WMD distance between those concepts and the two benchmarks. One benchmark again is from Red Dot, the descriptions of full award-winning designs related to jobs. The second benchmark is the first paragraph of UAV, describing UAV on Wikipedia, which provides the general benchmark of UAV, which is a job. Anyhow, so, and the results also show that the novelty of those AI-generated concepts is slightly related to the semantic relevancy between the source and target domain. Again, it suggests the controllability of AI-generated concepts by the distance, knowledge distance or semantic distance between the source and target domains for analogy. And later on, we worked on biologically inspired design with AI. Biologically inspired design is a special, very specific type of analogical design or design by analogy, which specifically draws inspiration from the nature domain for solving problems in the engineering domain. Engineers normally find it very hard to draw analogy from nature because we don't have good knowledge about nature for design by analogy or biologically inspired design. But AI doesn't have this problem. GPT-3 has already got a knowledge from nature, knowledge in engineering and many other domains. We just need to teach GPT-3 to be able to reason from the biology domain and to the engineering problem domain. In this case, we created a small data set of more than 200, almost 200, slightly more than 200 biologically designed examples from asknature.org for GPT-3 to learn about BID, design reasoning. And we hard-coded this into, fine-tuned the GPT-3 model into a web portal called innov.co. And this web portal has been used by some companies and researchers to generate biologically inspired design concepts for their specialized design problems. Some of the companies have already told us that the AI-generated concepts are quite reasonable, some of them, and inspiring, and some of them are also useful for their design problem and design projects. If you're interested, you can also try innov.org for to recruit our AI agent to generate the BID concept for your difficult design problems. And the concept generated with our AI models are actually represented in text forms. Those concepts represented in text can be inspiring for the human designers to read and get inspiration and generate new ideas, and also draw, sketch, and create visual embodiments of those design concepts for later stages of the design process. They can be also used as input into the latest text-to-image generative AI models like DALL-E and Midjourney to generate visual embodiments of the GPT-generated textual design concepts. So, so this work actually is the first to explore and experiment the uses of GPT for design concept generation in the early phase of design process. And design concept generation with GPT is different from ChatGPT that generates content, which is a common sense. The content generated by ChatGPT doesn't have to be novel and useful, but those are required. Novelty and usefulness are required for design concept generation. So we develop different data-driven workflows to ensure the GPT models can be fine-tuned or repurposed through future learning with our design data sets, and to think like a designer to generate design concepts that are novel and useful. And that requires a creation of data set which embeds target knowledge or creative reasoning logics for GPT models, the generic models to learn, and then conduct design concept generation, and rather than just common sense content generation. And our experiments actually show GPT's capabilities for design concept generation are actually controllable, as I explained based on the results of our experiments earlier. And our results also show some of the text generated representing concepts are actually of no quality, no validity. So that's that Mercian hallucination problem is very typical for autoregressive language models. And hopefully through more experiments in the future, as we improve the controllability of those GPT models for design concept generation, we can reduce the machine hallucination problem for design concept generation purposes in the future. And we explored a few knowledge sources and reasoning logics and different data sets for design concept generation with GPT-2 and GPT-3. And ideally, we hope to generalize and integrate those models, data sources, and reasonings in one place. So we can have something like ChatGPT and different designers with different design problems, different knowledge and reasoning requirements to go to use just one model for different purposes. And that's the goal. And GPT 2.5 and GPT-4 actually have already showing promises for such capabilities to be developed and such more general model and workflow to be developed in the model in the future for the use in design concept generation. And for the concepts generated by AI or human designers, we need to evaluate them in terms of novelty, feasibility, and usefulness. If we use AI to generate a concept, we're going to generate many. Then that requires automated concept evaluation. And that requires well-established, well-accepted metrics and benchmarks to evaluate the large number of AI-generated design concepts. And we don't have such well-recognized metrics benchmarks in the community. So in this experiment, we develop our own metrics, our own baselines, own benchmarks to evaluate the concepts generated by different AI models. Hopefully in the future, our community can, some research teams and through collaboration can develop some golden standards baselines for evaluating AI-generated design concepts. And that if that happens, then it's going to facilitate the development of many more AI models for design and applications. So in any case, in this study, we have run a few experiments and to show the capabilities of GPT for design concept generation. Particularly, we show such capabilities are controllable in terms of the knowledge used to be used for concept generation and the reasoning logic to be used for design concept generation. And eventually, the AI-generated concept needs to be human-centered. And we have to ensure AI generates human-centered concept. We haven't worked on that. We didn't report our research on this front. Actually, we have started working on developing a framework and now a computational capability for artificial empathy to be used in human-centered design. And Chihao is going to present this work at IDTC conference next month. If any of you is interested in this work, you're more than welcome to attend that paper session. And thank you for listening. That's my sharing of our research and generative pretrained transformers for design concept generation. I hope it's inspiring, and I'm happy to take any questions together with my co-author, Chihao. And thank you.